It's awesome to have an audience here that is so engaged and interested in this topic. Give yourself a round of applause. Thank you very much for showing up. I've talked to a bunch of you. For several of you, this is your first conf. Welcome. And hopefully you'll take something away from this talk that you can bring back to your peers and your management and demonstrate some value. For those of you that keep coming, go for it. For those of you that keep coming back, I hope you learned something. And I really am looking forward to sharing some of the knowledge that I've gained working with Splunk over the past so many years, and all the things that I've done that are dumb that I don't want you to do. Because I've done my share of dumb things over the time and don't want other people to have that same scenario. So without further ado, I promise this is one of the last times that this clicker will not work. OK, there we go. So this is going to be the last time you see the forward-looking statement. But for me, this is really awesome because I've never presented a talk where I've gotten to actually go through this with you. So with that said, let's go into the intro and agenda. I want you to learn things. I want us all to come away getting better at administering Splunk. And hopefully this is just going to be one of the technical talks that gets you thinking about different aspects of Splunk administration. So my life with Splunk, or why they let me stand up here and say things. So I am the Director of Technical Operations at Hurricane Labs. We are a Splunk partner and one of the first to do work with Splunk Enterprise Security as a managed service. I've talked to a bunch of you, and several of you are active clients, so thank you very much. I'm the team lead of our Splunk implementation team, and I do a lot of Splunk things for a lot of different clients. But I don't stand up here alone. I have a great team behind me that does really good work with Splunk and makes the work that we do for our clients go really well. So I really appreciate all their help, and I'm just kind of a spokesperson right now, but there's a lot of giants that I work behind that really help us do well. Whatever accreditations and certification I have the architects and admins and consultant, whatever they call it this week. It's changed multiple times, and I didn't know what this was called when I was making the slide deck. Fun fact, this is part of the Splunk community track. These talks were added in the past month. So everyone else had multiple months to prepare for these talks. I had a couple weeks. So this was a little bit thrown together at the last minute, but I think there's some really good content that's come from that. Finally, Splunk community. People have asked me how long I've had my Fez. The answer was since Monday. So I'm new to this. I'm new to people asking questions, but I'm really happy to be part of the Splunk community and kind of share that knowledge with everyone. Splunk user group in Cleveland. Cleveland is a beautiful place to be in November and December and January and other times of the year. We're close to Cedar Point, so that's awesome if you like roller coasters. Additionally, I have a bunch of writing that I've done on our blog and our tutorials on the Hurricane Labs website. And it's really awesome and humbling to have people come up and talk about stuff that they've read that I've done and how it's been helpful. So I say anyone who does that, talks to someone who writes something, it really makes a difference to them. So thank you for all that you bring that up. And I'm competition director for the National Collegiate Penetration Testing Competition, or National CPTC. This is the premier offensive security competition for college students. And we focus on teaching business skills and consulting skills in addition to offensive security. So how does that relate to Splunk? Well, everything in that environment runs Splunk. We capture every piece of data we possibly can think of and turn it up to the max. And my plan at the end of this year's season is to release all of that data as frozen Splunk buckets that you can ingest as a security data set. They've already done some really awesome research with that, and I'm looking forward to seeing what else comes from that as well. And finally, for those of you that are looking to learn more about Splunk administration, or if peers or coworkers that want to look at Splunk administration, I have a course on Udemy I've put together, the Hands-on Splunk Administration Guide. It takes you from nothing to having a Splunk environment in AWS, ingesting data, and building dashboards and searches in under 4 hours. So it's a quick gateway drug to Splunk that you might want to check out. So now I'm going to say something that's going to be sacrilegious to everyone that's been at Conf all week. But Splunk isn't perfect. Despite everything you've heard all the past couple days, there are things that can be done better. And that guy that's on every single slide, he's screaming. So they didn't actually, somehow they did not delete that slide. So I'm kind of impressed. But to get an idea of who you are, how many of you would say you're a Splunk administrator? Oh, good. I'm talking about administration. We have a lot of you here. Perfect. What about Splunk architects? You could also be the same people. So still a good amount of you. Splunk enthusiasts, hopefully that's everyone here, good, perfect. Splunk consultants, a couple of you. Recovering Splunk consultants. Yeah, I'm kind of in that boat. But my goal here, this is intended for various skill levels and experiences. There's going to be something for everyone. So regardless if you're an expert or a novice, you're going to learn something. You just might learn more depending on your skill level. And for those of you with experience, some of this is going to be review. But don't worry. It's things that are still relevant and also things that are still something that I find you still need to know. And you're going to find people that don't know this thing. And it's really a great opportunity to kind of share that knowledge. Everyone that I've shared this talk with practicing has learned something, regardless of their experience. So hopefully that applies to everyone in this room. So our agenda for today, we're going to talk about 3 main areas: configuration and configuration management. We'll talk about architecture, and we'll talk about data ingestion and quality. So there's a lot of gotchas and bad advice that I run into, and I want to share some of those so that you're better prepared. And then also we'll talk about designing Splunk correctly for your use case and your environment. And we understand that Splunk is the environment that you can ingest data for everything. But just because you can doesn't mean you shouldn't do some preparation as well for that. And the last line here is really important. Everything that I talk about comes from experience, working with hundreds of Splunk environments over many years. And this is all built on what I've seen, what I've learned, and what I hope I can share with everyone here. So we'll transition into our first part here, where we talk about configuration and management and how we customize Splunk without breaking it too badly. So this first example is going to be an easy one, but it's an important one. So a lot of you will probably be able to relate to this, but it's still something worth sharing. So default versus local in your configuration files. Do not ever modify anything in default unless you're writing an app. I've written apps. I'm sure there's some of you in the audience here that have written apps before. In that case, you're writing your configuration and putting it into the default directory. If you're writing Splunk, you can modify Etsy system default all you want. I have a hunch that most of you here are not writing Splunk. If you are, thank you for showing up. But you're probably not. And also remember that the highest level is typically going to be Etsy system local. That overrides everything except in some specific scenarios that I tend to forget sometimes, such as when you have slave apps on your cluster. That said, even though Etsy system local is the highest level, the best practice is to avoid making changes in there, because that can lead to some unsurprising or some surprising issues or make your administration a little bit more complicated. It seems like an easy solution at the beginning, but it can cause some problems down the road. So how does stuff end up in Etsy system local? Well, a couple options. So if you make a configuration in the web UI, depending on how you do it, it will sometimes end up in Etsy system local. It might also end up in the search app or the launcher app or another app, depending on how that context is in the URL. But that's a way that something can happen. Using the Splunk edit command, as you see in this example here where I'm doing an edit of the cluster config, that will result in configuration ending up in Etsy system local, as you see. If you use the MSI installer for Splunk, especially for configuring a universal forwarder, you'll end up with config in Etsy system local as well. And if you listen to advice, you'll often run into cases where someone will tell you, do this in Etsy system local. And I'm going to emphasize that's not necessarily bad advice in the sense of it will work. It's not necessarily the best advice for your environment. But that said, the person giving you that advice doesn't understand your environment and is trying to write advice that's generic, and you need to be able to adapt that advice to what's best. So it's more difficult. Putting things in Etsy system local is easy, but it's kind of a lazy way to do administration, and there's better ways to handle that. So you're thinking, like, what's an example of this, Tom? Well, we've seen Smart Store this week, and if you look right in the Smart Store documentation, there's a line there that says, make this change in Etsy system local. That will work. Better approach is to make an app for that and use that as a base config for Smart Store and push that out to your systems. To ride this a little bit more, though, why is Etsy system local a problem? Big one, universal forwarders. So when you have a deployment server configuration, this ends up in a file called deployment.client.conf. You could also have inputs configuration for reading, your Windows security logs or your Linux security logs or your auth logs. That ends up in inputs.conf. Outputs configuration, how do you send this to the indexers? Outputs.conf. That's all configuration that you need to have on a universal forwarder in order for it to work. But what happens if your deployment server changes? Well, hopefully you planned ahead and have a CNAME that you can just update. Not everyone is that lucky. I've seen plenty of cases where that's a server name or IP address. And if that is in etc system local, that's very difficult to update. And it's not practical to manually update every universal forwarder if you have 10, 15, or 150,000 of them. So, and someone in the audience is going to say, oh, Tom, you can use a scripted input and fix this. Yes, you can. But that's not all that clean. It's a little messy. You don't want to have to do that if you don't have to. So the key takeaway on here, everything you put in etc system local cannot be easily managed by the deployment server. And it can't be easily changed by the deployment server. So if you're using deployment server, and you should be, and we'll talk more about that later, you want to ensure that you're using that effectively and not using etc system local. Another case that I see is how do you get rid of something in default? So don't ever modify default, as I said. But let's look at this example here where we have a stupid app here that has your action eval to true, which is obviously not SIM compliant and just a bad thing in an app. You're going to find these things. You might be tempted, I want to take this out of default. No, don't modify default. Create a local config file, set your action to null, and then you'll see that that null action is what takes precedence. And I'm introducing a concept here of the Btool. And I want to go into that a little bit more, because that is a godsend for those of you that are stumbling into a Splunk environment that you haven't seen and want to figure out how things work. So this is the best way to understand what configuration exists on disk. That's an important caveat, on disk as opposed to what's currently running. So it'll be the configuration of Splunk that happens when you restart Splunk. There are many different flags, and we're going to go into a couple details about that as some of the examples that I find particularly useful. So this is an example of a base config for your inputs on a indexer. This is basically telling Splunk, hey, I want to receive data on port 9997. So you'll see right there, we have a stanza saying, hey, Splunk, listen on TCP 9997. And you'll see in that case, it's actually in the slave app. So this is a clustered environment and a clustered indexer. Now, what I like to do in this case is not necessarily run it where I see everything, because I don't really care that much about system default most of the time. That's config from Splunk. That's always going to be there. I care about the changes. So I use grep on the command line, and grep-v will remove anything with system default in it. And we get the configuration to be a lot more sane. We can see just the changes there from the default Splunk config. And we'll see our slave apps there is taking precedence, and that's the configuration that's applied. So this is a really simple example of how I might use this. But the options there where you specify a config file such as inputs are definitely something that you can change to identify all kinds of different config files. So any main config file is there. Additionally, by default, Btool doesn't take into account user and app context. But you can do this where you define a specific app and you identify a specific user. And you can use this to identify searches that are bad and what user is responsible for that, and use that to address some problems that you might run into. Finally, I want to talk a little bit about configuration, naming, and all of that. And the most important line on this is the subtitle. Understand when you build a Splunk environment that someone else will have to look at it at some point. It may make perfect sense to you, but I've walked into so many Splunk environments where I just need to spend a lot of time trying to figure out how it's behaving. And I see some people that I work with and some other people here that are kind of agreeing with me. So yes, that's a very true situation. So keep configurations and naming consistent. Have a convention that's logical and stick with it. So one that I like to do is if you have a config that's going to be inputs, include inputs in the name of there, and also possibly the product that you're doing inputs for. Same thing for props and also for indexes, any of those sorts of config files. It makes it easy for someone to say, oh, this is what this app does. And then please actually keep those things in that like the file. So like don't put outputs config in an inputs app because that's just going to drive someone crazy. And we'll talk a little bit more later about how that works with the deployment server and why you want to do it this way. But just for now, trust me. Additionally, this might be a lost cause, but I need to put it up here. Please, if you have any ability to establish a naming convention for servers in your environment, try the best you can to get that established as something that's logical, makes sense, something where I can look at something and know it's an indexer or a search head or a web server or something like that. I had a client one time that they couldn't tell me what server was a web server in their environment. So we ended up making everything a web server because we just didn't know. And that's not the best way to handle that. But if you have, SRV number, how the heck am I going to develop something in the deployment server to effectively apply config? So hopefully you can have some say in that, but like I said, a lot of times I run into cases where it's a lost cause. So that kind of wraps up some of the configuration side of things. Next, I want to move into architecture. So the important thing to keep in mind is Splunk lets you install as many Splunk systems as you want based on having a license. So you have a 50 gig license, you could deploy 150,000 Splunk instances. Is that a good idea? No, but you can. But the thing to keep in mind for this is we have the ability to design an architecture, we have the ability to make a lot of different design decisions. How do we come up with something that makes sense? So as I said, architecture is flexible, there's many deployment options, and just because you can do something doesn't mean you should. Just like anything in life, pretty much. There are some designs that are better than others, and I'm going to talk through some of that now in the next few slides. So let's go forward. So indexers and search heads, they are the most important part of your Splunk environment. They are the things that make the data something that you can grab and something that you can do things with in a reasonable and effective way. So if you have good indexer performance, you have good Splunk performance. The indexers are the most important part to having good search performance. And your CPU, your memory, and your disk I/O, those are all not suggestions. So I have seen many cases where clients are frustrated with Splunk. They have enterprise security, it's not working well, they're considering dumping the product, and they look at the system requirements like, hey, you need to add like 20 cores to your search head in order for it to be like good. They do that, Splunk works, the product is generating alerts, it just kind of saves the day. And all I do is just say follow system requirements. Finally, NFS, don't use it for your warm volumes, it's unsupported. Serby gave a great talk a couple days ago saying NFS stands for not for Splunk. And I think you should all keep that in mind. You can use it for cold, it is supported to do that. Should you? No. I've seen many cases where an NFS failure, even on the cold side of things, results in a cascading failure of all of the indexers. So if you can avoid using NFS in any capacity, obviously you're in a better situation. Smart Store does change some of that, but I'm still going to be seeing this sort of thing for quite some time, I'm sure. Also, ratios for your indexers and search heads. This is something that a lot of times people say, my searches are running slow, I need to add more search heads. No, look at your indexers first. You have to have good indexer performance first before you add search heads. And if the indexing tier is insufficient, adding more search heads just compounds the problem that you're having. So I see various numbers for recommended ratio, but 1 to 7 tends to be something that is recommended that I've seen. So just keep in mind a lot more indexers than search heads is the way you want to design an environment. And finally, premium apps. And this is kind of like the one exception where you might see fewer indexers compared to search heads than that ratio. If you have a smaller environment with less indexers, but you still are running a premium app such as enterprise security or ITSI. ES, ITSI, each of them separate search heads. Don't put other apps on there because you'll be sad if you do. That said, other apps don't include the necessary TAs, technology add-ons, to make field extractions work and knowledge objects. Those you still want to have. Once again, otherwise your product won't work too well. Now let's talk about forwarders. I hear a lot of advice about this, and some of it's not great. So universal forwarders and heavy forwarders. There's distinctions I want to make between the two of them. First, a UF is a lightweight Splunk installation that's designed for grabbing data. A heavy forwarder is a full Splunk Enterprise installation that's configured to do something a little bit different than an enterprise search head. UF does not include Python. A heavy forwarder does include Python and any of the other weight associated with running all of that. A UF is designed to effectively stream data to other Splunk instances, and a heavy forwarder is designed to be a Splunk instance. It's an indexer with config changes. So the key takeaway on here is universal forwarders are going to be more efficient. They take up less resources to run. They're more efficient at streaming data over the network because of how they process that data or how they don't process that data specifically. And if you're looking for which one to use, in most cases, the universal forwarder is going to be the right choice. And we're going to go into some more detail about that now. So when I first started working with Splunk, and I will admit I actually designed environments that had this sort of thing, but it was very common to see heavy forwarders in front of your indexers. I understand there are still some scenarios where you might need to do this, but hear me out for a little bit and let's go through why this is bad. I still see it in the field, but it is not recommended practices to have something in front of your indexers. You want to have your UFs talk directly to your indexers. So why? So let's look at it where you have a bunch of indexers, a bunch of universal forwarders, and a couple heavy forwarders. This is a very common design that I used to see. As you can see, you have two indexers that are very sad and a bunch that are very bored. You don't want to have bored indexers. They also are sad, but they feel left out. And you don't want to have those two indexers that are struggling processing all the data. As you can imagine, this is a terrible distribution of data, and your search performance as a result of this indexing performance is actually going to be very bad, because those indexers are going to be the ones that are primarily going to be used for searching data until load balancing happens. But still, it is not a good distribution of data. In fact, if you don't force automatic load balancing, those could be the only two indexers that get data, unless the settings are changed. So I'm sure someone's going to be like, well, Tom, they solved this with parallel ingestion pipelines. Cool. So there you go. You end up with a couple more indexers that are getting data, and you have still indexers that are bored. Someone else is going to say, hey, let's increase parallel ingestion pipelines a little bit more. Cool. You're just kind of spreading that out a little bit more, but you're still not addressing the core problem. So next, someone's going to be like, hey, Tom, we still want to have heavy forwarders, so let's do it the right way. So I give you this slide of where you actually have a reasonable ratio of indexers to heavy forwarders. And then someone is going to have to go, and I don't want to be the person who has to go to your boss and say, hey, I need like all these servers, especially for a cloud deployment that you got to administer. So it's a mess. This would be something that could be acceptable. Increase the parallel ingestion pipelines on these to whatever you deem acceptable. You could reasonably say this is fine, but you look at this, it's a crazy design to do that. So let's just remove that bottleneck, and everything just is happy. It's easy. There's less systems to administer. You send everything directly to your indexers. Automatic load balancing handles that, where you have nice data distribution, and all of your indexers are smiling and wearing sunglasses. So it's an easy way to fix that problem and address that bottleneck, and this is the design that you should be looking at. So that covers some of the environment and infrastructure. I want to transition next to talk about deployment management and how you can use the deployment server effectively. So, fun with deployment server. So how many of you run Splunk on Windows? I'm sorry. But so for those of you that are running Splunk on Windows, how many of you have a deployment server on Windows? Okay. Hopefully you don't have any Linux systems that you're managing with that Splunk deployment server. Which good, you're nodding, so you read the documentation. Thank you. I run into this still often, where someone has a Windows deployment server that's managing Linux hosts that is not supported. Linux deployment server can manage both Linux and Windows hosts. I'm a little biased. You see all my screenshots, they're on Linux. I understand some people are going to run it on Windows. I'm not going to judge your personal characteristics or anything like that. But just understand there are things that work better. But this is definitely a support issue where because of how permissions are applied on Windows versus Linux, Windows cannot manage Linux. And I've had to deal with that a number of times actually in the past year where I've seen clients that have tried something else. And documentation is helpful to back you up in that case. So that link actually goes to Splunk docs in case any of you want to question where I'm coming from. Which, no one in here would question anything someone says up on stage, so that's cool. So, deployment clients and your apps and your server classes. So what I want you to do when you're looking at your deployment apps is think of them like blocks. They are Legos for building a Splunk environment, and each of them should be single function if at all possible. You can use those just like Legos to build whatever kind of house you have, where you take an outputs app and an inputs app and a props configuration. You stack them all together to create a forwarder that does what you want. So you're probably thinking, cool, but that sounds hard. Why do I want to do it that way? Well, you use server classes to kind of build your houses out of these Legos, where you create a server class that accomplishes the tasks that needs to be done. And there's no limit to the number of server classes you create. So your server classes should also be fairly generic in these cases. Why? So this is going to dive into the deep technical stuff that no one really cares about until you realize it's a problem. But every time you create a server class and assign an app to it, there's a tarball that's created under the hood in the Splunk deployment server. So if you have 20 server classes that all have the same app, Splunk is creating 20 different tarballs with the same thing under the hood. So how many of you have dealt with a slow deployment server restart? I see some of you. That's often a symptom of that, where you have too many server classes that have too many tarballs that need to be processed. So a better way to handle that sort of thing is to, instead of putting in outputs in every single server class, create a more generic outputs class. Say you only have one data center, or you have the ability to send data to both data centers, or whatever your environment looks like. You might be able to have one outputs config for your entire Splunk configuration and apply that to every universal forwarder. That significantly reduces the overhead. Even if you have a couple where you have like one data center in one country and one in another country, you can have separate outputs for that. Hopefully you have a sane naming convention for those servers and you can identify what country it's in and send that data based on the outputs. Apply inputs separately, have a separate server class for that. It'll still work. But generally, that's the advice that you want to have. Make those very small and purpose-built, and don't combine that configuration because it's going to cause Splunk to be a little bit slower. And once again, I'm really pushing the logical names for everything. But coming from experience, I have seen so many cases where stuff just doesn't make sense. And that's hard for anyone that needs to operate with an environment they're not familiar with. So let me show you a little example of how we might lay out some of this in forwarder management. So you'll see right here that your apps are created based on what they're trying to accomplish. So we have an app here that's all Windows. That would just have base configuration for Windows. So if there's like security logs we want to have from every Windows system, you can put it in that server class. Whereas all your universal forwarders, that might contain configuration like disabling Splunk-D so that it's not remotely available over the network. All heavy forwarders, if you have those for certain reasons, not in front of all your data sources that we talked about, that's another case where you might want to have that as well. And anything like this, it makes your deployment server more easily understandable. So if you want more detail about this, I have an in-depth tutorial on the deployment server and some of these under the hood details that you can check out. And a lot of this is based on stuff that I learned the hard way. So check that out. Also, I'm sure the slides will be posted later and these links will work. You'll be able to find this information. Next, I want to talk a little bit about Splunk.Secret. This is something that I find a lot of people don't think about, but reading through the professional services chat in Splunk, I see a lot of people having to deal with it. So Splunk.Secret is basically the encryption key that Splunk uses to encode passwords. Encode being the specific word here, it's not encrypted, it's encoded, because Splunk has to basically decode those passwords to use it. But it avoids keeping passwords in plain text in your config files. And for those of us that are security people, which all of us think about security, at least in some capacity, it's good to not have plain text passwords in config files. So having Splunk.Secret being consistent allows for encrypted config files to be distributed via your deployment server and not have a situation where something doesn't work. Great example of this, authentication.conf for connecting to LDAP, for example. Your bind end password, you don't want to just have that sitting out there where someone can see it in a config file. So push out an encoded version. Keep your Splunk secrets the same. We have an article on Hurricane Lab's website about how to do this if you want to fix this, if you don't have a consistent Splunk secret. And then there's a tool that my colleague Steve McMaster wrote that lets you actually do work with Splunk secrets. So you can take an encrypted or encoded password out of a config file and the Splunk secret, reverse that, and use that to migrate to different things. So that's a great tool. A lot of people in the Splunk community have used that. So finally, we get to our last bit of technical knowledge in this, but data ingestion and quality. So this is when I apply all of the sales engineer or sales rep training that I've done where oh, schema on the fly. It's literally the only time I've said that actually is here saying that in this slide. But that's fine, I don't sell Splunk, I just work with it. But it doesn't mean you can't plan ahead. So Splunk has been talking the past couple days about they want to be the data to everything platform. That's cool. That doesn't mean that you can't be prepared and better equipped to bring in that data as you're doing it as opposed to trying to fix it later. Like everything, doing something right at the beginning is easier long term than doing it wrong and then having to fix it, especially once business processes are revolving around data that isn't in the best format. So, source types. How many of you have ever made up a source type? I see a lot of you. How many of you felt really dirty when you did that? I see some of you. So, obviously, don't make up one if you don't have to. If there's something that's defined for it, go ahead, use it. Like I always like to say, if someone did the work for you, don't redo their work, unless you can improve upon it. But if you have to make up a source type, and I will say I have to do it all the time because people have log sources that are unique to you. You have custom products. It's something that happens as a Splunk administrator. But make it a source type that makes sense. So a recommended format I would say is your vendor:product or vendor:product type is a good way to do that. And also avoid configurations that result in _ too small happening. And this is one of the cases where I need to yell at Splunk and the Nix TA because they have this config where there's no source type specified. And that by default will try to automatically assign a source type, and you'll end up with name a file _ too small. And that's a problem. It's messy. So you can solve that by explicitly creating input stanzas that define the source types. Finally, data ingestion from third cloudy products. Heck is the way to do this if you can. Why? So, third-party APIs, landmine sadness, adventure. Pick your own adventure novel. A lot of times the main character dies and ends up on an abandoned island and you don't get any data. But this is one of the cases where every third-party API is different and they don't necessarily think about what makes sense for your environment. And obviously you know your environment more than they do, but they make a lot of assumptions. And we all kind of know what happens when people make assumptions. So if you have an option between using a heavy forwarder and an app, making an API pull, or using HEC, choose HEC every single time. Streaming data is more efficient, and HFs have limitations in this case. So first thing, if you're running an app on an HF and it's doing a pull, there's going to be a delay because that API has to make a call out on a regular basis, whether that be 5 minutes, 10 minutes, 1 minute, whatever it is, it's not real time. Second thing, there is not a good way to handle high availability or failover or redundancy in that scenario. If you have something that's reaching out to an API that can only really run on one heavy forwarder at a time, you could still have your config somewhere else, have it disabled and pull it. It's still something you have to intervene on. Whereas if you're doing streaming with HEC, you have a load balancer in front of it, you already are high availability. And if an indexer is down, it'll just send that data to other indexers. So it's a much better solution. Finally, this is something I do all the time, but don't be afraid to talk to the vendor or the app developer. They are not Splunk experts. You are the Splunk experts. but they are experts in their product. So anything that we can do as a community to better prepare people and better equip them to work with Splunk and also share their knowledge of their product, we all win. So I do this a lot of times. It's resulted in there being better apps that come out on Splunk base, and we all win. So there's no reason not to do that if you can. Not every vendor will work the same way, but try it. The worst thing that can happen is nothing, but go for it. But the key takeaway here, stream data whenever possible. That's where HEC comes into play. Using Universal Forwarder comes into play. Stream that data. That's the way that Splunk naturally ingests data and works best. And finally, one last bit of advice. I see this way too often where you will have onboarding advice and it'll say, go into inputs, create a UDP input, name it syslog, and I just sit at my desk and start crying. Because what happens, you restart Splunk, data's lost in UDP. You don't want to do that. So I could give a whole talk about how the right way to handle this is, but as a high-level approach, it's going to be some form of a syslog server running syslog-ng, writing files to disk that get ingested. You could be using Splunk Connect for syslog they were talking about in the demo labs downstairs. But understand the person or the vendor writing those directions is not following necessarily the best Splunk best practices. Modify the instructions. And then you can adapt it. You can still use their app often for the knowledge objects, but you just have to know more than the person that's giving you the directions. And that's kind of the ongoing theme of this. You know your environment best. You're the Splunk experts. Apply that knowledge. Don't just blindly follow someone else's instructions. So, yay. Let's get to the wrap-up. Finally get to not hear me talk, which is probably exciting for some of you at least. Hopefully not everyone. But all of this comes with experience. I stand up here working with Splunk for 5+ years, working with hundreds of different environments for different clients. And I've been burned by many things. I want to share that with you so that you don't experience the same thing. There will be things that change as I have more experience. Some of this advice will be different in a couple years. But we learn from that, it changes. Don't be afraid to ask for help, though. I ask for second opinions all the time from my peers and coworkers. They do the same for me. Same thing. Ask the Splunk community. Reach out in the Splunk Slack, ask on Splunk Answers, talk to other people that know Splunk, randomly send me emails, I'll try to reply. Anything like that, ask for advice. But then when you get that advice, understand that it's advice that may work, it probably is good, but it may not be the best for your environment. So like advice that says, hey, do this thing in Etsy System Local. It'll probably be fine, but it's not the best approach. Do what makes sense for your environment, tweak that advice, and keep these guidance in mind. And finally, once the slides are available, download them, reference them later. It'll be a good reference that you can share with other people. And I definitely plan on sharing that with other people when they ask me questions. So a couple resources. Obviously, Splunk Docs and Splunk Answers are great. The Splunk Community Slack, if you haven't signed up for that, hop in. You can get in there and ask all kinds of questions, and there are plenty of people that are wearing the Splunk hat that can help you out. And then some of the tutorials that I've helped write and many of my peers at Hurricane have helped write. Feel free to reference those. I generally say if I have more than 2 or 3 people ask me how to do something, I like to write something about it and share that out there. And a lot of people find that helpful. So before I take questions, I want to just point out this is the last of 5 community talks. It's really important for you to rate this so that we can encourage Splunk to have talks like this in the future. So if you all just take a moment, rate this talk, and we would help have more content like this in the future. So with that, I will go back to the question slide, and feel free to ask me anything that you have. Just before questions, I have to say this is a phenomenal audience at this point in the conference. Thank you for your attention. You've all been great. I really appreciate it. So I saw one right there.
So you're suggesting using the hack input method for getting data out of the third-party clouds, right? So most of the Splunk TAs will work with the hack data format, like for example Splunk TA for AWS or Splunk app for AWS. So that will not work with the hack JSON format.
Okay, just to make sure I heard that correctly, you're asking about Splunk formats like in AWS where it won't work with the Splunk HEC format or the Splunk JSON format. I didn't quite grab the end of that.
Yeah, so like the Splunk app for AWS, will it work for the HEC data format? We use HEC imports.
Gotcha. So basically the fundamental problem you're getting to is there is an assumption that's made with a certain app that the data is coming in a certain format, and that's not applicable to when you ingest it in another format, essentially. So it's expecting an API pull and what the data looks like. You're getting it in HEC format. It doesn't necessarily translate. So that's one of those situations where it's a bit of a challenge sometimes because the vendor has to write the app to assume a certain thing. I've tweaked apps in that case to update them to work with the better format. It's not the cleanest option, but it really comes down to what problem you're trying to solve. Do you want to have the data in real time and have it in a way that's more reliable, or do you want to be able to use this app? So it does vary for that. My advice is still focus on the ingestion side of things and make sure you get the data in a reliable format, and then tweak the TAs and knowledge objects to make it work with that. That can be a little bit more difficult, but that's what I found has worked well. So you had one?
How many deployment clients would you say would be the max to run on a single deployment server, and what tweaks would you do to that?
Gotcha. So the question was, how many deployment clients do you have on a single deployment server, and what tweaks would you do? So this is one of the things where it varies, obviously. I have seen the Splunk docs number says about 2,000 with a 12 core, which is obviously pretty low for a lot of deployments. You have to be careful about increasing the check-in interval. If you set it too high, it can actually cause problems where and we actually saw this at a client where it doesn't keep checking in, so you might have a case where it takes so long for something to download that it just doesn't work. And I don't remember the exact technical details about that, but it was like setting it more than an hour or 30 minutes or 15 minutes, some number of time was way too long for it to be a stable deployment environment. So that's one of the challenges for that. I say once you get into the some number of thousands is when you're pushing what a single deployment server can do. And you have to look at turning off the feature where it keeps there's some config change, and I don't remember the parameter off the top of your head, but it keeps it consistent across the two, because you can't have deployment servers that have a different, the way it does that tarball, so the hashing will be different, and if it connects to one, it'll be constantly loading the app if you have a load balancer in front of it. That's the setting you have to change. But then keeping it in sync, I wish there was a mechanism Splunk had to actually allow you to do that, but right now they don't, so it's a little bit of a mess. But it's an interesting problem to solve. Yeah. Yeah, you're welcome. Who else? Any other questions?
So, in our environment, we have Splunk Cloud.
Yes.
What would be better, to use syslog data to a heavy forwarder, or just use universal forwarders and all that?
Okay, so the question there was, in a Splunk Cloud environment, what is better, to have data come from all of your Linux systems via syslog to a heavy forwarder and send that to Splunk Cloud, or put universal forwarders on your machines and stream that over the internet to Splunk Cloud? So the second option would be better if you can, where you have the universal forwarder sending data to Splunk Cloud directly. And that's really two reasons. It's a fidelity issue, where you're basically using a higher quality way to send that data, because syslog, it can be a little bit limiting, and you still have to put that configuration everywhere. Universal forwarder is great because if you need to add a data source, say you turn the system into Apache web server at some point, you just push that config there, and now you're getting those logs. Whereas syslog, you don't have that level of granularity. The second issue is anytime you're using syslog, you're relying on network resiliency for ensuring that that data is reliable and not getting impacted. Obviously, you'd probably be using TCP, so at least has some level of protection, but there's not the buffering that you get with Splunk to Splunk protocol. So that's kind of another benefit for that. Plus, syslog is not compressed over the network. Splunk to Splunk is. So you're actually saving on bandwidth by doing that as well. And you eliminate that bottleneck, single point of failure on-prem, and basically the thing I had with the slide where the one system was sending all that data. You have a bunch of systems spraying that across all your cloud indexers.
Yeah, because, because the previous one, previous session yesterday, they talked about the lazy beast death.
Yeah, exactly. So I think I know what talk you're talking about. There were some fundamental differences I had between that talk and this one, but obviously this is going to be one of those cases where we're probably going to agree to disagree. But I try to avoid the laser beams of death whenever possible. And having that all, removing that tier entirely is the best way to do that. Yeah.
Right now I've got universal folder across thousands of machines, but I'm not going to be able to open a firewall, go directly to the cloud. So what do I do to concentrate that, send it across view?
Yeah, you're in that scenario where you might have to make some difficult decisions for that. My recommendation would be see what you can do on the firewall side to allow that, just because you are not allowing 9997 to the internet. You're allowing it to specific destinations in the internet. And you generally can make a case for, these are the 5 IPs I'm sending data to, I need to allow this to, from my network over 9997 to these specific IPs. It's a very specific source and destination combination. I understand that's not possible at every organization. But that would be the first thing I would recommend. Try to do that directly to the internet, to Splunk Cloud, if you can. If you can't, then you're looking more at the design where you don't want to have a single choke point for that. So I don't know how big your Splunk Cloud environment is, but let's just say you have 5 inputs IP addressed to that. You want to generally look at have at least double the number of heavy forwarders or even universal forwarders to send that. And that might be a case where you don't want to use heavy forwarders, you want to use universal forwarders for that, to route the data. Because a heavy forwarder does parsing and actually makes the data that gets sent larger. Using universal forwarder will be more efficient for that sort of thing as a choke point. But yes, and instead of using a heavy forwarder, use a universal forwarder as that tier. And then look at the number of indexers that you have by running a search, looking at the Splunk server in your search results. See how many you have in Splunk Cloud. Try to have double the number of that as your aggregation tier. Kick up parallel ingestion pipelines to whatever ensures that you're not killing the CPUs on those boxes. And they're at least trying to solve that problem, but it's more complicated than trying to get that firewall exception in place, unless you're in a certain industry where you can't do that. So it depends, but present the business case, and this is why this makes sense, and a lot of times I have success with that. Yeah, you're welcome.
So I've seen your Splunk.Secret Python script, which you used in the
His Splunk.Secret Python script.
So does it also work with the Splunk passwords, the user passwords?
No, the user passwords are one-way hash.
Yeah.
Yes. There is a command line argument to generate the hash, but there's no way to reverse it.
It was okay. I was just doing that.
The best option for that is if you have a hash that you know what it is, you can just replace it in Etsy password, and it'll work. But it's a standard Unix password hash.
Yeah, but the thing is, it's not the humans, it's for the non-humans. So I had to update password again with all the scripts for reasons. So that's why I wanted to see the
Yeah, if you're just updating the password, it'll like the Splunk secrets tool will actually take you give it a password and it'll spit out that the hash. But there's no way to go backwards.
Hi. What if you need to do filtering? And so that we have everything on heavy forwarders, which is, I know, not the best. And actually, several of them could just be universal forwarders. We do have certain requirements because, we're already very close to our ingestion license. So we're trying to do
Everyone else is too.
So I'll give you the example, like Windows event logs. We don't need all the informational events. We just really need the errors. Can universal forwarders do that job of filtering?
Certain things. So a universal forwarder can filter Windows events with a config
Before sending it.
yes. So that's totally possible.
So where's the real difference? Like I know it having the Python script. So if I'm handling, let's say, payment information, and I have to process, then I would assume that has to.
That is something that's more on the prop side of things that you can't do on a universal forwarder. Are you cloud or on-prem?
On-prem.
On-prem, okay, so you can still do that on the indexer level if you're sending UFs directly to the indexers. And basically that's configured to push out through your cluster master, typically assuming you have a clustered environment, and apply that to all the indexers. You don't need the heavy forwarder tier for that. That said, it can make it a little more complicated because there might be more change control around doing it on the indexers versus heavy forwarder. So it can make it a little bit more difficult, but the end result is you have better distribution of data. But it's totally possible, at least. Yeah.
We have all our heck inputs coming through a set of 4 heavy forwarders which are load balanced.
Mm-hmm.
And I just wanted to understand what would be a good time to scale the heavy forwarders out, or is it good practice, or it should go with indexes, the heck points, or basically understanding the health of your heck points and capacity plan accordingly?
Sure. So, yeah, so the question there was about heck, and they have 4 heavy forwarders that are all load balanced and receiving that. The next question I would have is, how does that relate to your indexers?
Whether it would be good practice to have it on the heavy forwarders or on the indexes directly, and how do you scale them out, and at what point, like capacity plan and scale them out?
Okay, so we want to know about scaling. How many indexers do you have?
We've got 6 plus 2 in making.
Okay, so about 8 indexers. Okay. So that's one of those, it depends sort of things. I don't necessarily see a lot of cases where they have that many heavy forwarders doing heck processing. A lot of times it's 1 or 2. But that said, you're adding there's probably not necessarily a reason for processing that data on a heavy forwarder, and an indexer could do the same thing, because you're just basically telling heck to listen and have that config. So you're essentially creating a similar bottleneck, especially if you're getting a lot of data in via heck. So
Better off on the indexing tier.
it would be better on the indexing tier, yeah. And especially if you're looking at scaling, if you're having capacity issues, it's all of your indexing at that point. You just add indexers to increase that and tell your load balancer, hey, spread this across 8 indexers, 10 indexers, as opposed to having another thing that you also need to scale. So that generally anything you can do to remove that level of complexity is better. But it's a change to how you're doing things too, and there might be a reason why it has to be somewhat like in a DMZ or something like that. So that could be a case where it might not be possible.
That is separate.
Yeah. Sometimes you can use the load balancer to get around those sorts of things, but it's like I said, every environment's different. So.
It was just put in because it was easier for us to scale out our heavy forwarders compared to indexes, which are virtual machines, and heavy forwarders are just virtual, so we can get them on demand.
Yep.
That was the reason behind it. And
Which kind of as a proof of concept makes sense. I just think, yeah, having the indexing tier handle that is going to be better if you can. Yeah.
I just wanted to add on to that. The DMC should have some stuff where you can monitor like the actual throughput of the heavy forwarders, and then just making sure that, like I would keep an eye on, is your heck data properly balanced across all the indexers?
yes,
It might be working just fine.
it is
It's
for
just
now.
something to keep an eye on.
Yeah, it is for now, but I haven't come across a guideline for like this much data and these many servers and this much capacity, because you get those kind of guidelines when you're talking about the indexing tier. You don't get much around the heavy forwarder, which is also doing other stuff.
Yeah, which heavy forward is essentially an indexer without disk. So from a CPU perspective, it's doing the same thing an indexer is, and it's streaming that data in more heavyweight format than a universal forwarder would be or a heck would be.
That is not running that searching tier.
Yeah, yeah. So the thought was in the past that, yeah, having that would take some load off your indexers. It actually causes the indexers to work harder to process data as opposed to getting that data in from other sources. So, yeah.
I have a comment and a question. The comment is, this is the kind of session why I come to .conf.
Thank you. So make sure that's in the mobile app. So thank you very much.